Hello students, welcome to Unit 1 Notes, Section 1-2. We did most of these notes in class. I'm just here, just going to finish them up for you. So we went over domain and range, we went over functions, we went over intervals, open, closed, semi-closed, half open, finite, infinite, went over radical and radical functions, just general domain and range of polynomials and rational and radical functions. We went over even odd and did some examples. So where we left off was example 5 here from the textbook, graphing piecewise functions. And what I was able to do was introduce you just a little bit to looking at the constraints here. So for this function, y equals negative x, it's graphed before 0. So when x is less than 0. Y equals x squared is graphed between 0 and 1. And then y equals 1 is graphed when x is greater than 1. So what I did was I just took all three of these and wrote them y equals. And when you look, here are our constraints. It looks like x is less than 0, so I put a line here just to represent where it's going to start and go in this direction. Y equals 1 is going to be graphed over in this direction, and then in between here quickly will be y equals x squared. Okay, and so I did already graph y equals 1. It's a horizontal line, and it goes on forever in this direction. The next one I'm going to graph is y equals negative x plus 0. That one's pretty easy to graph. It's going to start with an open circle. The graph of this one is down 1 over 1. But the thing is, I'm not going to graph it in this direction. It's only going to go in this direction. And so I'm going to move that to be a little bit clearer right there. Oops. That looks good. And it goes on forever. This is y equals negative x. Y equals negative, here, give me 1 second. Y equals negative x plus 0. That's your y-intercept is 0. I am going to just remove that because it's not needed. And remove that dot because that's not needed. So here's 2 of the 3. And the last one is going to be between 0 and 1. Oh, it looks like I made an error here. Oh, I froze the program. Give me a second. There we are. So I actually made a little bit of an error. What I'm going to do is I'm going to move this equation because I forgot this counts by 2. All right, I'm going to move this over just a little bit. There we go, because this line should be right here, right? That's 1, 1, because the graph of this is between 0 and 1. So I just adjusted it because I made the error counting by 1/2 here each time, not 1. So let me erase these now. And for this last one, the equation, you know what, let me change it to purple so it's a little easier to see against the orange. All right, so y equals x squared between 0 and 1. Well, it's 0 squared is 0, 1 squared is 1, and a parabola will open up like this. And that is it. It might even be a little bit less. Let's see. 1/2 squared is a quarter. No, that looks pretty good. Looks like I went through a quarter right there. All right, and that's our piecewise function. Notice I used open circles where it was less than or greater than, and I used closed circles to be inclusive where it was less than or equal to and greater than or equal to. All right, so let's write a formula for this one. This one looks like the line, if I were to look at this line forever, looks like the line y equals x, y equals 1x plus 0. because it looks like the slope is up 1 over 1 with a y-intercept of 0. And this one, let me just move this now a little bit over here. That looks like similar, but not the same thing. It looks like it's actually the line y equals 1x minus 1. And the reason for that is it looks like we have a y-intercept at -1. So here, let me leave that line right here so that you can kind of see. That makes sense? All right, now I'm going to erase it. So we are writing the piecewise function. Well, where does each one of these start? Well, here we go. So I'm going to say f of x equals, and one of our lines is 1x plus 0. I'm just going to call it x. And the other line is 1x minus 1. I'm going to call it x minus 1. And I'm going to say that x is between I'm going to say x is between 0 and 1. So 0 is less than or equal to x is less than 1. Notice that this first one is inclusive, the second one is not. And then this one has both of them inclusive. So I'm going to say the next one is between 0 is less than or equal to x. Oh, sorry. 1 is less than or equal to x is less than or equal to 2. And that is it. I'll even use the same exact notation. Y equals these. All right. Here's a transformation. We have the absolute value of x minus 2. All take away 1. So the first thing I'm going to do is I'm going to graph an absolute value function through the origin, and I will move it in a second. So here we are. We have an absolute value function through the origin. And this one is y equals absolute value of x. And we are going to move it 2 units to the right. And the reason why it's 2 units to the right is because what number would get me a 0? 2 minus 2 would be 0. So we are moving it to the right 2 units, which is right there. And now we're going to move it down 1 unit because that is a vertical shift down 1. And there we go. So that is now the absolute value of x minus 2 all minus 1. Let me try to make the absolute value a little bit nicer. All right. Now the domain and range of this, well, the domain is all real numbers because nothing is affected. I can put in any inputs I want. And the range is going to be all real numbers greater than -1. Well, and so what I need to do is I need to hard bracket this, -1 to infinity. Soft bracket. We are done with that. The last thing, I think this is the last slide for now. It's the composition of 2 things. So this is asking us to compose f of g, where g of x is this item, f of x is this item, and it wants us to find f of g of 2. So the first thing I want to do, if possible, is put in 2 wherever I see my g function, x, wherever x is, I'm going to put in 2 wherever x occurs in the g function. So I'm going to say g of 2 is equal to 2 squared. So g of 2 equals 4. Awesome. And so now what I'm doing is I'm going to replace 2 of g with 4. So f of 4 is truly what I'm going to evaluate. Now, where does 4 go? Well, 4 goes in for f. So here I have f of 4 equals 4 minus 7. And so f of 4 equals negative 3. And finally, I write it as f of g of 2 equals negative 3. Now, that's not the way everyone does it. Some people might instead substitute g in for f, and that's totally okay. So here's another example of what we could do. So this is version 1. This is version 1. Here's version 2. Oh, this happens sometimes. Gets a little funky. Okay. Here's 1. This is option 2. We could have just evaluated x squared wherever we saw an x. So f of g of x would have been x squared minus 7. That's totally fine. You can put in x squared wherever you see an x. That's going to happen. So f of g of x, so f of g of 2 now is going to be 2 squared minus 7, which is 4 minus 7. So f of g of 2 is going to be negative 3. And that's okay too. So either way you want to do this, it's like working backwards. The first thing you have to focus in on is the innermost, which is this x. If the x isn't a value like 2, then leave it x. Put in x where you see x squared, and that will get you x squared. And then you're putting all of this in, g of x. What is g of x? It is x squared. So x squared is going to go in for f of x. So x squared goes in here, and then you get x squared minus 7. We just had a number that we were able to evaluate. So it made it a little bit easier, or maybe more difficult, but all right. And so that's the end of the notes. So I will let you get to the rest of the lesson, and I'm going to make the next set of notes right now for Monday. All right, thanks. Good luck.